session, we will talk about stack as a linked list. Now let us first understand what is a linked list. Linked list is a collection of non-contiguous memory locations. These memory allocations are known as nodes. The linked list can be represented in memory like this. Each of these structures are called nodes. In each node, there are two parts. The first is the data part and the second is the address part. Each node is known by its address only because they do not have any name. So, for implementing a linked list, the address of first node is stored in a special type of pointer. Here we store the address of first node. Now the first node, this is the data part, and the address part of the first node contains the address of second node. Second node contains data and the address part contains address of third node. Now the third node is the last node of the linked list. It has again two parts. The first part contains data and as there is no node further in this linked list, the last node contains none in the address part, which indicates that this is the end of this linked list. Actually, in memory, these nodes are created at scattered positions and every node keeps track of the next node by retaining the address of it. So, the first node contains the address of second node so that it can reach the second node, and second node contains the address of third node so that it can reach the third node. Now let us see how we can create nodes in C++. In C++, to create nodes, we use structures. Let us see how we can create it. Now to create a node which can store integer type of data, I will create a structure like this. Int num. This is the data part and the next part will be the address part. This part will be created like this. The data part will contain only num here and you can store as many data as you want by creating more data members here. And the address part is created by this statement. Here next is a pointer of type node. And this type of structure is called a self-referential structure because it contains a pointer of type itself only. The type of this pointer next is of node type because it is going to store the address of node only. So it has to be node type only. Now to further implement the stack, I need to create a variable top. In a linked list of type, in a stack of type linked list, this top is a pointer variable which is created like this. Again the type of top is node because top is also going to store the address of node type only. Now the top, the function of top is to keep track of the top position of the stack. And initially, I will initialize this variable top by the value null, which indicates that it does not have any address and initially the stack is empty. Now to create a node. Now let us create a node. Node is created using the statement node star ptr is equal to new node. Here new is an operator which creates or allocates a memory of the type given after it and it returns the beginning address of this memory. In this case, new will allocate a memory of type node. It will allocate memory like this which has two parts, the data part and the next part. You can say num and next. And the beginning address of this memory is returned by new operator which is stored in the pointer type variable ptr. So the memory representation of this statement is like this. This is a pointer type variable PTR which contains the address of this node. Now I have to attach this node to the linked list. In the beginning, there is no node in the linked list and my stack is empty. So I will first check whether this node has really got allocation or not, because it might be possible that the RAM is full or the memory is full and no node can be allocated memory. So to check that, I will write the statement if PTR equal to none. I will say cout stack overflow. Which indicates that the memory is full and no more node can be allocated to the stack. Now to add my very first node to the stack, I will write down the statements ptr arrow num equal to the, suppose I want to add 10 to my stack, ptr arrow num is equal to 10 and ptr arrow next is equal to top and top is equal to ptr. See how these statements work. Now using the very first statement, the value 10 will be assigned to the num data member of ptr. And when I say ptr arrow next is equal to top, the address stored in top will be stored here. Now in the beginning, my top is null because this is the beginning of the stack and there is no element in the stack. So what will happen? This will be null now. It will store the value null. Now when I say the statement top is equal to ptr, the address of this node will be stored in top. Address of first node. Which is indicated in the memory by this diagram. This shows that top is pointing to this node and the value stored in this node is 10. And the address part of this node is null, which indicates that there is no more node in the stack. There is only one node in the stack. Now if I want to add further new nodes to the stack, again I will give the same statement. Node star ptr is equal to new node. Now this time again, a new node will be created in the memory and the address of this node will be stored in ptr. Now I repeat this set of statements again, and instead of storing 10, I will store 20 this time. So my first statement will store 20 in this. And my next statement, ptr arrow next is equal to top, will store address of first node here. Now when I say top is equal to ptr, now top will point to this node. It means this relation will no longer exist and now my top will point to this node. And this node is pointing to this node because it is containing the address of this node. So in the memory it will appear like this. This is top pointer which contains the address of first node in which 10 is stored, and first node contains the address of second node in which 20 is stored. And the second node contains 10 and there is null value stored in the second node, which indicates that there is no node after this node. So again if I want to add one more node, see, I will again add like this. I will create a node like this using this statement. I will add data to it, suppose 30. 30 will be stored here. Now using this statement, the address of this node will be stored here. This address of this node will be stored here. So it will point to this node. And top will contain the address of ptr. It means top will now contain the address of this node. And when the function ends, this ptr variable will be deleted from the memory. So this is how we can add more and more nodes to our stack. Now let us see how we can delete a node from a stack. Now to delete a node from a stack, let us say we have a stack like this, which we have just created. This is top, this is 30, 20, 10, and last node has value null. Now to delete the very first node, I will store the address of this node in a temporary variable, pointer variable. The statement for doing the same is node star ptr is equal to top. What will happen? A variable ptr will be created in the memory which contains the address which is contained by the top. Now to delete this first node, my top should point to this node instead of this. The address of this node is stored here in the next part of the first node. Now to store this address in top, I will give the statement like this. Top is equal to top arrow next. So using this statement, top arrow next contains the address of second node which will be stored in top. So top will contain this node, contains the address of second node which will now become the first node. And now I have to delete this node. So please make sure that when you create a node using a new operator, it is necessary to delete it using the delete operator. So I delete this node using the statement delete ptr. When I say delete ptr, this node, this memory will be deallocated and it will return to the heap from where we allocate memory for nodes. One more thing is there. If there is no node in the linked list and I try to delete a node, it will give me stack underflow. This can be written as if top equal to null, cout stack underflow. It means I am trying to delete a node from a stack which is already empty. So this is all. Now we will see a program which shows the full implementation of stack using classes. So this is a program to implement dynamic stack or stack as a linked list in C++. As you can see, I have created a structural node which has two parts, the data part and the address part, which is node star next. Now I am using a class to implement this linked list. In a class, for stack as a linked list, I need to have one pointer type variable top which will keep track of the top position of the stack. Now in the public section, I will declare a constructor stack which will initialize top by the value null, because in the beginning there is nothing in the stack is empty. That is why top is initialized by the value null. Now we have three operations: push, pop and display. Now you can see in push operation, I have created a variable temp of type node, and temp is equal to new node. This statement will allocate a memory of type node and the address of it is returned, which is stored in temp. Here I am entering data in the temp node, and these two lines, they indicate how we can insert the node in the stack, which I have already explained earlier. Now this is the pop operation. Again I am checking if top is null, you cannot delete a node from the stack, and again I am storing the address of first node in the temp variable, and using this statement I am pointing the top to the next node so that I can delete the first node. Now delete temp will delete the first node from the linked list. Now this is a program to display the stack. Now I will initialize a variable temp by the value top, and I will use the loop which will go from top till the value null, and I will keep on displaying the data using the temp variable, and I will move to the next node using the statement temp is equal to temp arrow next, which will move to the next node because it contains the address of the next node. Now the program execution will start from main. First I will create an object of class stack and then a character just for input operations, and in the do while loop I am giving all the three operations whether I want to push, pop or display. Now to push in the stack, if I have to press P, when I press P, it will go to the push function, which is here. It will create a node. It will ask you to enter data for the new node, and then the new node will be inserted using these two steps. Similarly, I can push more nodes, and then to pop a node I will press O. It will go to the pop operation and it will pop the very first node. And then the third one is display. Using a display function, I can display my stack from top till bottom. This is all for stack as a linked list.